If you had a group of man-made chemicals that underpin our modern lives, enabling safety and innovation as well as convenience, yet you prove that these same chemicals can have a grave impact on human and environmental health, how would you tackle that challenge? That's the question that the worldwide community has been asking themselves about PFAS, per and polyfluoroalkyl substances, a class of over 15,000 chemicals that we've been using since the mid-20th century. The carbon-fluorine bond is the strongest single bond in organic chemistry, and that's what makes PFAS so thermally and chemically stable and able to repel water, dirt, and grease. The list of applications is long: nonstick cookware, textiles like outdoor clothing, cosmetics, paper lining, ski waxes, firefighting foams, and any number of industrial applications like sealants and semiconductor fabs. They can be the more classic long-chain PFAS, like PFAS, which was used in firefighting foams, down to the ultra-short-chain PFAS, like TFA, an important solvent in organic chemistry used to make pharmaceuticals. I'm Lauren Former, PFAS subject matter expert and bioinorganic and environmental chemist at ISLE. My work has always focused on removing contaminants of emerging concern, CECs like PFAS, from water using advanced treatment, but also smart management and sound evidence-based policy. The PFAS challenge is huge, and it confronts us with many issues in our sustainability and circular economy goals globally. However, that is a challenge that we can overcome together through collaboration, and solutions are already here. At ISLE, a global clean tech consultancy, I have the joy and the privilege of working very closely with the municipal water and wastewater utilities, industries, the technologies develop PFAS removal and destruction solutions, investors, and regulators and policymakers. Each of these stakeholders has an important role to play in PFAS management, and there's a few key things for each of them to keep in mind. When it comes to the municipal utilities, they probably have the most immediate challenge in measuring and removing PFAS because the regulations are now in place to ensure that they're also providing consumers with safe water. PFAS treatment, however, is a carefully balanced trade-off, socially, economically, and environmentally, because these technologies can be very energy and carbon intensive, not to mention expensive. That's why proper risk assessment and clear objectives are essential. And also not to forget, as we're thinking about removing PFAS, are all the other CECs that are relevant to health and might be regulated in the future. The same applies to industries who, especially if they produce and or use PFAS, are now also responsible for finding suitable alternatives where they can. Some estimates say that if we only focus on PFAS treatment at the municipal utilities, so removing the PFAS as it continues to be collected in the environment because those utilities are only the concentrators and not the sources of the PFAS, and we don't focus enough on making and using less PFAS, those costs can exceed the global GDP, and that's just not realistic. So the reduction in the use of PFAS and source control is essential for industries, and it's also where the regulators and the utilities will be looking first to reduce PFAS in the environment. This can be particularly tricky for legacy contamination sites, especially when that PFAS load needs to be contained there at the site. But regardless, it's important that industries now look specifically at PFAS treatment and abatement, and also stay ahead and remain competitive in looking beyond just PFAS and acknowledging the responsibilities that they have for contributing PFAS to the environment, while also looking forward at all the solutions in the future. Speaking of solutions, the technology companies that develop PFAS removal and destruction solutions, their biggest challenge has been scalability. Most end users have been quite reluctant to adopt new technologies, though part of our mission here at ISLE is to accelerate adoption of innovation in the market. And there are proven and cost-effective at-scale PFAS solutions already here. And part of the PFAS health threat is this not knowing. However, as PFAS technologies are in their development stages, some of the major pitfalls that they face are developing a reliable and suitable system, as well as business model that makes sense for real-world utilities and industries and also offers that assurance also legally, that PFAS goals are being met and compliance is in place. Globally, we are seeing an uptick in the investment in PFAS technologies in response to these regulations. And at ISLE, with our global perspective, we know what exists and what makes sense. And we also have the ability, that's the core of our work, doing the technical due diligence on whether these technologies are doing what they claim. And all of this fits into a very complex and constantly evolving global patchwork of regulations. Yet regardless of which stakeholder you are, what's very important and essential is clear and transparent communication about PFAS without fear. Again, PFAS is a challenge that we can overcome together, also and especially in the water sector. Please feel free to reach out to me and us at ISLE, because we've got this.